section, we have already covered the concept of the area between the curve and the x-axis. But in this section, we will try to extend this idea and find the area between two curves. And we just learned that in order to find the area bounded by two curves, we have to find we have to compute a definite integral from a to b. A and b are the vertical limits, vertical boundaries, and then we have to take the values of the greater value function f of x minus the bottom one g of x, f of x minus g of x. And we know we did have the theoretical session about explanation of this formula. That means let's just practice. Let's find the area which is bounded by two curves, f of x and g of x. That means I will pick a few questions from the textbook. Sketch the region enclosed by the given curves and find its area. And the first question is question number 9. And the first curve is y equals to square root of the quantity x plus 3. And the second curve, let's say y sub 1, y sub 2, is x plus 3 over 2. Okay. That means always having two curves, let's start to find the points of the intersections. Points of intersection. It means the first curve, x plus 3 square root of this must be exactly the same like x plus 3 over 2. Okay? We will square both sides. I will square this. That means this will be just x plus 3 with the domain x being greater than negative 3. And this will be x plus 3 squared over 4. Okay? And then I can multiply by 4 both sides. Okay, that's square. And I will subtract x plus 3 squared from both sides, and then I can factor out the common factor, which is x plus 3, and then 4 will stay here, and another x plus 3 will stay from the second term, because I pull out x plus 3 and x plus 3. Then we do have x plus 3 and 4 minus x minus 4. We have really nice factored form, 1 minus x. That means x is negative 3 or x is 1. That means negative 3 and 1 are the x coordinates of the points of intersection. Okay, let's try to get the graphs. Okay. Square root of x plus 3 is the function square root of x, but shifted 3 units to the left. So that's the graph. Okay, this is square root of the quantity x plus 3. And then the second graph is just the linear function x over 2 plus 3 over 2. That means it's the linear function with the slope 1/2. And of course, the x coordinates negative 3. That means this will be, because that's the point of intersection. Okay, that means this is the line, and we did calculate this point, it's 1. My scale is a little bit off, but we have the correct labels. Okay, that means the region which is bounded by these two curves is actually here. And we can nicely see the top function, and we can see the bottom function. The bottom function is simply a line. Okay, that means the area will be defined as a definite integral from negative 3 to 1. The top function is the square root of x plus 3 minus this one. Okay, and then we can try question number 10. That means it's the same thing. We have to find the region enclosed by two curves and find the area. And the curves are sine of x, and the second one is 2x over pi. Okay, that means this is just the sine function, and this is linear function with the slope 2 over pi. We can intuitively, by observation, we can draw this function because we know how function sine looks like. Okay, that's the sine from 0 to pi only. And this is gonna be, oh, we have to go through 0, 0. I'm just trying to, okay, 0, 0. And we still have to find out that point. That's not 2, that's the question mark. That means points of the intersection, sine of x equals to 2x over pi. And this one is not easy to solve algebraically because we do have analytic function, we have trigonometric function, and we have algebraic function. That we can try to guess the answer because this is 2x over pi. And this has to be, that means for what values of x, both of the sides will be the same, okay? And if I will put sine maybe of pi over 2 and substituting pi over 2, we're getting actually 1 equals to 1. That means x is pi over 2, okay? And we can, this is supposed to be in the middle. I can maybe change a little bit my sine function. Okay, that means this is exactly in the middle, pi over 2, and that's pi. And this is, of course, 1. Okay, that means this one is not easy. One more time, I will just do actually x. I was gonna point x. X is pi over 2. Okay, and we did get the same on the left. Sine at pi over 2 is 1, and 2 over pi and pi over 2 is 1. And that means this is like a little bit different way to get the points of the intersection by observation. And this is the loop bounded by these two curves, and the same thing. The area is the integral from 0 to pi over 2, the top function, sine of x minus 2x over pi dx. And let's try to integrate. Integral of sine is negative cosine of x. Integral of 2 over pi x is the 2 over pi, and x squared over 2 from 0 to pi over 2. Okay, integral of, substituting the upper limits and lower limit, cosine at pi over 2 minus, I can definitely cancel out these 2's. I will substitute instead of x pi over 2 squared and another pi in the denominator stays. That's the upper limit minus the lower limit. Negative cosine at 0, and then if I will put 0, it's just 0. Cosine at 90 is 0. This will be pi squared over 4, but pi in the denominator will cancel out, and then negative and negative will give me positive. Cosine at 0 is 1. Okay, that we do have the answer 1 minus pi over 4, and this answer is correct. Okay, we did have some. Okay, that's actually pi over 4. Okay, excellent. Okay, let's solve another one. Question, I think I was asked, okay, question number 15. Two curves. The first one is secant square of x, and the second one is 8 cosine of x. Okay, that means this one we can definitely try to find the points of the intersection. I think would be not difficult, but also would be nice to see the graphs. And we expect from our students to know cosine of x, but we don't really expect cosine square, secant square of x. That means I can draw it for you. Cosine function, of course, looks like that. That's pi over 2, that's negative pi over 2, that's 1. And secant, it's something like parabola, secant square. That means this one is secant square of x. Of course, we will not really expect this type of function, okay? Secant square of x. That we can nicely see, that's the loop between, so easy to set up the integral, but we still need to know that question mark and that question mark, points of the intersection, points of intersection. Let's see, points of the intersection, we have to say that the secant square of x is the same like 8 cosine of x. Secant square of x is 1 over cosine square of x, 1 over cosine square of x, 8 times cosine of x, and let's multiply, that's cosine. Let's multiply both sides by cosine square, then I will have cosine cube of x. Actually, let me divide by cosine cube of x, and then if I will take the cube root, I have cosine of x, it's equal to 1 over cosine of x is equal to 2, then I can flip, cosine of x is 1/2. Cosine for what angle is 1/2? For pi over 3, and of course for 5 pi, but we will use the 4th quadrant in this, the negative notation, since we have the x-axis. Okay, that means this looks like pi over 3, works well, and negative pi over 3. Okay, so we do have points of intersection. An integral that represents the area is the integral, and I will actually use the symmetry. Okay, let me just integrate from 0 to pi over 3 and multiply by 2, because I will only cover that part, and multiplying by 2, I'm covering the other part. And the top function is 8 cosine of x minus the bottom function is secant square of x. Okay, let's try to integrate. Let's keep that too. Integral of cosine of x is just sine of x. Integral of secant square of x is tangent of x, because derivative of tangent is secant square of x from 0 to pi over 3. Okay, let's substitute the upper limit, sine at pi over 3 and tangent at pi over 3 minus sine at 0 and tangent at 0. However, that 2 is affecting everything, but sine at 0 and tangent at 0 is 0. That's when we can skip that part. Sine at 60 is square root of 3 over 2 times 8, of course, and also times 2. Tangent at pi over 3 at 60 is square root of 3. That's what we have. We have 4 square root of 3, or minus another square root of 3 times 2, which is 3 root 3 times 2, 6 root 3. And let me just check my notation. I think, yes, I did. This is the correct answer. Okay. Let's try to solve another one. Question number 19. We do have two curves. The first one is cosine pi x, and the second one is quadratic function 4x squared minus 1. Just the parabola shifted 1 unit up. Okay, and this is cosine. We have a little bit different period, but it's still like cosine function. I mean, I can draw cosine curve. It's still, yeah, it's something like that, but let me just, it's cosine. That means I will just draw, and this one we have to make it, because it's not negative pi over 2 and pi over 2, because of that pi, I think it's just half and negative half, but we can try cosine and pi must be 0. That means pi over x, cosine for what angle is 0? For pi over 2 and for negative pi over 2. That means x will be just half, okay, because we're dividing. That means this is, since we have that pi, we're losing that pi in that x value. That means this is half and this is positive half, okay. That's the zeros of the function. Again, it's a little bit complicated function, but it's still not bad. And then this one is just the parabola shifted 1 unit down. And if I will take this parabola, 4x squared minus 1 equals to 0, if I would like to find the x-intercept, I will have 1/4, taking the square root. I have square root of 1/4, which is the same values. That means parabola will go through the same x-intercept. Okay, that means this is 4x squared minus 1, and this is cosine pi x. Okay, because the same thing, points of the intersection, if I will take cosine pi x and 4x squared minus 1, I don't know if we can easily get that value. We just know this by inspection, by observation, and by solving the x-intercept of the individual function. Okay, and then the same thing, the area which is enclosed by these two functions is this, and we can set up an integral. I can again I can use the symmetry. I can only set up an integral from 0 to 1/2 and multiply by 2. And the top function is cosine pi x minus parabola 4x squared minus 1. We have to remember to distribute that negative. Okay, and we can try to compute this. Okay, let's try to integrate. Integral of cosine pi x is sine of pi x and dividing by pi. Minus integral of 4x squared is 4x cubed over 3. Negative and negative will be positive. Integral of 1 is just x, from 0 to 1/2. And we still have to double, because my limits of integration is from 0. Okay, let's substitute 1/2. Sine at pi over 2 over pi minus 1/2 to the power of 3 will be 1 over 8 and plus 1/2. If I substitute 0, I think I'm getting all of the zeros. We don't even have to write down, but I will. Okay, sine at pi over 2 is 1. This one is 1/2. 4 times 1/8, 1/2. 1 over 6 plus 1/2. Okay, that means we can try to 2 times 1 over pi is 2 over pi, and then this one I can say 6 and 3, right? 1/2 is 3 over 6, that means 2 over 6, which will be 1 over 3, okay? Just a little bit of arithmetic, but that's the correct answer. Okay, that means the next question is, let's speed up a little bit. Question number 21. Question number 21, we do have the curve cosine of x. And the second curve is 1 minus 2x over pi. Okay, that's mean question 21. We have cosine. Again, will be not easy to find the points of the intersection, trigonometric function and algebraic function. But cosine function looks like this one. That's pi. That's 0. That's actually pi over 2. I'm sorry. This is pi. Okay. And this one, it's the linear function with the y-intercept 1 and negative slope. That means it's something like that. I still don't know. I am guessing, because what we can do, points of intersection, which is cosine of x, must be the same like 1 over 2x over pi. And if I substitute 0 for x, cosine at 0 is 1, and if we put 0, 1 minus 0 is 1. That means 0 definitely works. X equals to 0. As we can see, because this is 1 and we have to go through 1. However, I can also put pi over 2 and I can put pi. That's all of the points of intersection, right? Because if we will put pi, let's put pi instead of x. Cosine at pi is negative 1. 1 minus 2 is also negative 1. That means x equals to pi works also. And pi over 2, let's try to check pi over 2. Cosine at pi over 2 is 0. And if I will put pi over 2, I have 1. 1 minus 1 is 0. Okay, that means pi over 2 works. And we do have these points. Okay, that means that's the points of the intersection, again, by observing. And this is the loop, is that part and this one. We can definitely see that it's symmetric. That means I can just set up one integral from 0 to pi over 2 and multiply by 2 to cover both parts. And the top function is cosine of x, and the bottom is that line. That means we will have cosine of x minus 1 2x over pi dx. Okay, we can try to evaluate this integral. Okay, that means let's try. Let's don't forget the two. Cosine. Integral of cosine is of x is sine of x minus integral of 1 is x. And then negative and negative will give me positive. I can put 2 pi, that's the constant, and integral of x is x squared over 2, from 0 to pi over 2. Okay, let's try. This will be upper limit, sine at pi over 2, pi over 2. And of course, we just saw this is gone. If I substitute pi over 2 squared, I will have pi squared over 4 and another pi from the denominator. And then 0 will give me 0. I will not put 0. Sine at pi over 2 is 1. This will be pi over 2. And this one is pi over 2 also. Oh, hang on, because my answer... let me check if I am correct. This is definitely good too, but did I make, oh, this is actually 4, right? It's pi gone, but 4 will stay. Okay. That means we do have 2, 1, half and a quarter. The difference is quarter and the negative. Okay, that's mean distributing 2, I have 2 minus pi over 2, and that's the correct answer. Okay, I have 2 more. The next question is question 23. The first curve in this question is cube root of 2x, okay? And the second curve is 1/8 of x squared. Okay, both of them are algebraic function. Probably we have no problem to find the points of the intersection. That means we know how cube root function looks like. We can start with drawing. Then we will intuitively see the values. Okay, that means cube root of x. Cube root of x looks like something like that. Oh, we should go through. Right? It's the inverse function to x cubed. And it's almost the same. It's a little bit lower, the values too. I mean, a little bit higher actually, but we can leave it like that. That's the cube root function, cube root of 2x, okay? And this is just parabola. Parabola, but multiplied by 1/8, that means a little bit like wider. A little bit, oh, like that. Okay, that means this will be because all of the values are lower. Okay, and we're looking for that point. And the loop between is just this, because this is not intersecting. Oh, 1 second. Question 23 has the limits. We do have a vertical limit. That means, let me correct this. I didn't realize, because we have to take this function from 0 to 6. That means x is from 0 to 6. I mean, I believe the 6 is here. That we do actually have, but we still have to find this point of the intersection, because we will have two integrals. That means let's try to compute point of the intersection, points of intersection between cube root of 2x and 1/8 x squared. Let's cube both sides, then we'll have 2x. Oh, 8 cubed is not a nice number. And x squared and cube, we will multiply both of the exponents. That means let's multiply by 8 cubed, both sides, 2 times x, 8 cubed and x. Okay. But what we can do, we can try to figure out, because 8 is 2 cubed and another cube, and I can divide by x, which actually not really dividing by x. X equals to 0 is the point of the intersection, and we can definitely see this. Let me keep this because we can't miss it. That means this is 2 to the power of 9, and to the power of 1 will give me 2 to the power of 10. And I will subtract x to the power of 5. Okay, quite impressive equation. That means now I can factor out x, 2 to the power of 10, and x to the power of 4. And now we can see x is 0, or x to the power of 4 is 2 to the power of 10. Which this means that I can square, I can take the square root of both sides. This will become 5. If I will, am I correct? Oh, something is wrong. This is actually 6. Probably I was thinking right away about, that means this is 5. When that's the moment that I will 5, then I can actually take the fifth root, right? Let me write this. If I will take the fifth root, this will be x, and this will be just 2 to the power of 2, because we can 10 divide by 5. Okay, 4. And even makes sense. my labels, my graph looks quite good. Okay, that means this equation again is quite, first of all, it's possible to solve it. It's not like the previous one, the trigonometric one. Okay, and now we know what to do. We simply have to set up an integral, but we have to set up two integrals. The integral for the first region and for the second one. Let me set up the first one. Okay, this will be an integral from 0 to 4, and the top function is the cube root of 2x minus parabola 1/8 x to the power of 2. And I believe you can solve it. And the second one is the definite integral from 4 to 6, and the top function is parabola minus the cube function. Okay, and then you can try to solve it. I can tell you the final answer. That means you can try to get, actually you can just, because the final answer looks quite, because of this cube root, looks funny. That means make sure that you know how to set up the integral. Don't worry for the solution for this one, okay? But it's important to know how to set up. Okay, and the last question is question 25. Question 25 is, where is my question 25? We do have a function x to the power of 4, and the second function is 2 minus absolute value of x. And we don't have any limits. Okay, that means we can draw it. Y equals x to the power of 4 is it's almost like parabola, but it's a little bit flat at 0. That means it's kind of like, I should be more, it's a little bit like that, okay? And this one is, we know absolute value of x, negative will flip the absolute value, and 2 will shift up. That means this is the absolute value upside down, shifted 2 units up. Should be nice and symmetric because both of them are the even functions. Okay, that means this is 2, and I'm guessing we need that question mark and we need this question mark because the area enclosed by these two curves is this. That means we can use the symmetry, but we still need the points of the intersection. Both of the functions are algebraic functions. We shouldn't have any problems to find the points of the intersection. Okay? We can still try to figure out by inspection, okay? Because what we think, if I will put 1, I think 1 to the power of 4, 1 minus 1. This is 1 and this is 1. That means it makes sense, the left and the right hand side. And if I will put negative 1, it's the same situation. That means this is negative 1 and this is 1. Again, it will be possible to solve, but it's a little bit too long. That means please remember, if you can see the points of the intersection right away, you may use them. Of course, make sure that both of them satisfies the left and the right hand side. Okay, that means let's just set up an integral. I will use the symmetry from 0 to 1. That means I will only integrate that part and multiply by 2 to cover the second part. The top function is actually this one, okay, the absolute value, and minus parabola, I mean x to the power of 4 dx. Okay, let's maybe integrate this because it's interesting parts, the absolute value. That means we will have 2, and then it's 2 minus absolute value of x minus x to the power of 4. Actually, I just rewrite this. Okay, integral of 2 is just 2x, and absolute value of x, we have 2 different ways to solve it, because for x, if x is actually positive, we can see, because we can rewrite this function. How can I do this? If x is just positive, that means that's what we're looking for, the positive x. The formula will be just 2 minus x, right? Because absolute value of positive number is just the same number. But if x, this is only for x positive. But if x is negative, we will have negative. That means we will change for positive, for the positive, because negative and negative will give me positive. This is for negative. And we can see that's correct. X plus 2, this is that part, positive slope. Negative x plus 2, negative slope. That means I can remove actually the absolute value. That means it's not really big deal anymore. Okay, that means I can keep it, and let me put here. Okay, now we can integrate. Integral of x is just x squared over 2. Integral of x to the power of 4 is integral x to the power of 5 over 5, from 0 to 1. And then we have to substitute 1, 2, minus half, minus 1/5, and substituting 0, we actually getting 0. That's we don't have to. Okay, what we can do, maybe we can get the common denominator, which is 10, 20 over 10 minus, this will be 10, 5, and then 2. Am I right? Because this is half and this is 1/5. Okay, guys, we do have negative 7, positive 13. Positive 13 over 10 and positive 13 over 10. 10 and 2 we can cancel out. That's the final answer. Okay? That means make sure that you have 2 equations. I can even write this down. This line represents, it's represented by 2 minus x. This line is represented by 2 plus x. And we're using that part. That means I'm using 2 minus x. Okay, thank you.